We continue to learn the HyperFun modeling language. This is the list of supported HyperFun primitives and operations. Before we consider primitives, and this lecture is devoted to operations. There are operations included as special symbols. Other operations are provided as library functions. There are several things to note in using operations. Linear transformations are mathematical space mappings, and they are implemented such that they modify the input point coordinates, which are later used in primitives. Usually the input array x is copied to some temporary array xt to be used as the first argument of operations. This is done just to save the input array x unchanged. This line is used to change the array xt by scaling operation. Note that in the next line, the array xt is used explicitly in the equation of the sphere. The resulting ellipsoid as the scale sphere is shown in the left bottom corner. There are also shift and rotation operations. The use of these operations is similar to scaling. Deformations or nonlinear transformations are also space mappings, and they also modify the input point coordinates. The tapering operation is extension of scaling, where the scaling factor changes linearly on some specified interval. See the following line in the given example. It defines that scaling is applied along the axis x on the interval from -3 to 3. At the beginning of the interval, the scaling factor is 1, and at the end it is 0.5. This tapering is applied to a superellipsoid shown at the top right, and resulting deformed superellipsoid is shown at the bottom right. Other supported operations are twisting and stretching. Twisting is a generalization of rotation with the rotation angle linearly changing on the given interval. Stretching is scaling in respect to the given point in space. The use of these operations is similar to tapering. Now let's consider operations for the combinations of the primitives. These operations are set-theoretic operations. Suppose primitive A is a blue box and primitive B is a yellow sphere. There are special symbols for the set-theoretic operations. The symbols for union and intersection operations are shown on this slide. Subtraction operation is described by the following symbol. The described set-theoretic operations produce objects with sharp edges as the union of two superellipsoids shown in the upper right. Blended version of set-theoretic operations generates smooth edges with added or removed material. The format of the blended union operation is shown at the top. It takes two objects as input arguments and three additional numerical parameters. Edges in the lower right image are blended by added material, which is controlled by the parameter A0 of the operation. Positive A0 means added material. Negative A0 removed material. Parameters A1 and A2 control the shape of the blend. Two superellipsoids are placed as in the previous example. Their intersection results in a shape with sharp edges as shown in the right middle image. The blending intersection with removed material results in a shape with smoothed edges shown in the bottom left.